Students, today we are going to study unit number 6, that is multi-threading, exception handling and applets of object-oriented programming, part 1. In this part, we are going to study regarding multi-threading. So first of all, we'll see the introduction of multi-threading. One of the exciting features of Windows operating system is that it allows the user to handle multiple tasks together. This facility in Windows operating system is called as multitasking. We'll see the definition of thread now. That is, definition of thread is a tiny program running continuously. It is sometimes called as lightweight process, but there lies difference between thread and process. So the below table shows the difference between thread and process. The thread is lightweight process, whereas the process is a heavyweight process. The thread do not require separate address space for its execution. It runs in address space of process to which it belongs. But in process, each process requires separate address space to execute. Therefore, it is a heavyweight process. Now we'll see what is the difference between multi-threading and multiprocessing. Just now we have seen multi-threading. Multi-threading means handling number of different classes, uh, sorry, number of different processes is called as multi-threading. The thread is a fundamental unit of multi-threading. The program or process is fundamental unit of multiprocessing environment. The multi-threading, multiple parts of single program gets executed in multi-threading environment. But in multiprocessing, multiple programs get executed in multiprocessing environment. In multi-threading, during multi-threading, the processor switches between multiple threads of program. But in multiprocessing, during multiprocessing, the processor switches between multiple programs or processes. In multi-threading, it is a cost effective because CPU can share among multiple threads at a time. In multiprocessing, it it is expensive because the particular process uses CPU, another process has to wait. Multi-threading, it is highly efficient. In multiprocessing, it is less efficient in comparison with multi-threading. In multi-threading, it helps in developing efficient application programs. In multiprocessing, it helps in developing efficient programming operating system programs. Now we'll see the life cycle of a thread. Whenever a new thread is created, it goes when it is executed, it goes into runnable condition. When it is in running condition, it can be stopped. Therefore, we have to wait by using wait function. We can stop the thread in a timed waiting condition also. For that, we use a function name that is time waiting, or the runnable thread can be blocked also. For that purpose, we have to use IO request. After the runnable thread is completed, it goes into terminated form and the program is executed. When we create a thread, the thread can be of various states such as runnable, waiting, blocked, and so on. After successful completion of thread, it gets terminated. Just we have seen in earlier slide. In Java, we can implement the thread program using two approaches or two different ways, that is thread class or runnable class. In the diagram, we can see that is the run method can be executed using thread class or runnable interface. But we have to see that is whenever we use thread class, at that time we use keyword as extends for using thread class. And whenever we use runnable interface, at that time we have to use the keyword as implements to implement the runnable interface in the run method. Now we'll see how to write run method, or what is the syntax for run method. The run method is most important method in an threading program. By using this method, the thread's behavior can be implemented. The run method is written as given shown below. That is public void run, and the run part body part is written. Now, how to write or execute or extend a thread? So there are three different simple steps for extending a thread or writing a thread. First step, the main class must extend the thread class. Second step, the thread is created in constructor using the start method. This method initiates the execution of thread. Step 3, override the method run by writing code required to execute a thread. Now we'll see how this thread is extended or created or used using run method with a very simple program. In this program, I have created one class having name thread demo. As we have seen in earlier slides that it has to extend by using thread. Therefore, I have written extends keyword and thread. Here I have declared one variable str which is of string type, and the string is empty string. You can see this. Then I have created one constructor or function having same name of that of class. Therefore, it is called as constructor, that is thread demo, and in which I am passing one parameter, that is string s. Now this string s is put into str, and as we have seen in second step of earlier slide, we have to initialize start execution of thread. So I have used the method as start. Afterwards, in third step of earlier slide, we have seen public void run we have to write. In that, I am executing the run method. For that, to show the execution of run method, I have used one simple statement, that is system.out.println, and I am printing the string str. Afterwards, I have written another class, that is public class thread create, thread underscore create, in which I have written the main function, and in main function I am creating the object of thread demo, that is t, which is equal to new thread demo, and in this I am passing the string which is to be displayed whenever the run method is executed. So you can see in the output one thread is created, hence the thread is in running condition. In this way we can extend or use the run method in multithreading. Thank you.